point and a slope. The name tells you what you need. Now, it's like when you go to a railroad crossing, it's a crossing that the railroad makes. We know what it is when we look at it. The name tells you what it is. So example number 1 here, let's say the slope is -2 and the point is 1, 3. Okay. So I'm going to write y minus y1 equals m x minus x1. And the value of m is -2. That's pretty straightforward. This point I'm giving you, though, is x1, y1, x1, y1, okay? It's not x and y, it's x1, y1, right? So this is y minus 3 equals -2, x minus 1. So I put that value in for x1, that 3 in for y1. I'm just substituting numbers. Okay, does that make sense?
Yes.
Okay, not too difficult, right? So let's do another example. Let's say this time the slope is 3 and the point is -4, -2. Okay. So it's always good to write the equation of the line. Y minus y1 equals m, x minus x1, like that. Your slope is 3, boom. X minus -4, okay? Y minus -2. So whenever you see a double negative, what do you think you have to do?
You have to put and there you go into positive.
Makes it positive, okay? So what you have to do here is rewrite it with that, okay? If there's a double negative, okay? And you're
Okay.
done. You're done. Like right here, you're done. There's nothing else to do. You are done. Why do you think I'm emphasizing that? You ever run a 100-meter race?
Yeah.
So when you get to the finish line, do you keep running as hard as you need to?
No.
No, you stop because you're done. Like you're done. You don't need to do anything else. There's this I don't know what to even call it, but in math class, you sometimes think, oh, there's more to do. I got to do something else here. No, you are done. You are done. Okay. You are done. Is that clear?
Yes.
Okay. So let me have you try one here. Let's say the slope is -3 and the point is 1, -5. I want you to write it in that point slope form we just talked about.
Y plus 5 equals -3, comma x, or parentheses, -1.
Is there anything about that you found difficult or you feel like would be difficult to remember?
No.
Okay, good. All right, so we are going to kind of redo some of the exercises we've already done in some way. Let me grab a problem set here. All right, so much easier to go out to the internet and get them. All right, so here we go. Let me grab this. So first thing I want you to do here is a new problem, is I want you to determine the slope between these 2 points, please. Give me the slope, please.
It's 2.
Okay, are you fairly comfortable with that?
Yep.
Okay. So let me just write it here. 4 minus 0 over 4 minus 2 is 4 over 2, which is 2. Very good. So now if we write y minus y1 equals m x minus x1, we know the slope is 2, but which point do you think we should use?
4 minus 0. I mean 2 and 0.
Okay, you can actually use either one. Okay, you can actually use either one. So we will use the first one though. So we're gonna use the point 2 comma 0. So that's your x1 and that's your y1. So it's y minus 0 equals 2x minus 2 like that. Okay. Now you typically don't leave the minus 0 in, so it would actually be written as 2 times x minus 2 like that. Even though that might look a little bit awkward. Is that okay?
Yes.
Now, what's interesting is that if we use the other point, so let's say we do the point 4 comma 4 now, we end up getting y minus 4 equals 2 times x minus 4. And believe it or not, these are exactly the same line, meaning both equations are for the same line. Do you find that hard to believe?
No.
That's good. Usually have to convince students that they're the same. Okay, so here's how you actually prove that these are the same. That's what we're going to do next. Okay, you actually solve for y. Now, on the left, it's already solved for y, but it's not. You've still got this parentheses over here on the right. So what it really means is you have to distribute in and solve for y. So on the right here, you get 2x minus 8. What do I do on this right equation here to solve for y? How do I undo this subtraction by 4?
You add 4.
You add 4. So now it becomes y equals 2x minus 4. Are these the same?
Yes.
They are. Right. So kind of proof that that they are the same equation. Okay, let's do another one here. Actually, I don't like any of those points they're giving you. They're making it. All right, so here's another one. Okay, so I want you to first determine the slope. We're gonna kind of just step through this. First, determine the slope.
-1.
You are correct. Good. The slope is -1. So now what I want you to do is pick either point, doesn't matter which one you pick, and write it in that point slope form.
y equals -1x plus
Okay, so
2.
hang on. No. So you're not giving me the right form. Y minus y1 equals mx minus x1. That's all I'm looking for.
Y minus -4 equals
Well,
-1.
so you can't leave it like that. So if you're going to do that, y minus 4 equals -1, x minus 2, you have to then simplify the signs. Y plus 4 equals -1 times x minus 2. This is the final answer in point slope form.
Oh, okay.
Okay. Okay, that's what I meant by point slope form. I was looking for you to put, it didn't matter which one because they're both correct. Doesn't matter to me which one you do. And teachers would grade either one. But then now like that's part A of the problem. Okay. Part B is to write in slope-intercept form, which means that you have to solve this for y by distributing the negative and then moving the 4 over.
Okay.
Is it clear what I'm asking you to do here? Do you needs me to different?
Is it y equals -1x plus 2?
Close. I mean, so yeah, real close. So when you distribute the negative, that's really where most of the issues occur. So it becomes negative x plus 2, and then you have to subtract 4 from both sides. So y equals negative x minus 2, like that. My guess is you didn't distribute the negative completely.
Yeah.
Okay. Yeah, that's kind of important. All right, let's try another one here. So we'll just do this in steps again. This is kind of a formal test sequence where you first determine the slope like we've been doing, and then we'll write it in point slope form, and then we'll convert it to slope intercept form. So go ahead and calculate the slope on this, please.
Is it -7?
I believe it's +7. No, I'm sorry. It is -7. Yes, you're correct. Good. Okay. So now you choose one point or the other, doesn't matter which one, and put it into point slope form. Point slope.
Y plus 5 equals -7x plus 2.
So if you're using this point on the right, that's x1, that's y1, it's y minus 5 equals -7x minus a -2. And then this minus stays as is because there's not a -5 there. it's -7 times x plus 2. So unless there's a double negative, that's when you change the sign.
Okay.
When there's just a single one, you keep it.
All right.
All right, so now I want you to take this equation. I want you to solve it for y by distributing the -7 to both and then moving the -5 over.
Okay. Y equals -7x minus 9.
Okay, let's take a look here. So sounds right. Y -5 equals -7x minus 14. Add 5 to both sides. Y equals -7x minus 9. Good, good. All right. Really, really good. Okay. So we've got to do some with fractions, okay? So let's just say I give you a problem where m is 1/2 and the point is -6 comma 4. Okay, so could you first put this into point slope for us, please? Point slope form for us, please.
Okay. Y minus 4 equals 1/2 parentheses x plus 6.
Really good. Okay, so this time when we solve it for y, when you distribute in, you get 1/2 x plus 3, right? Half of 6 is 3, y minus 4. Add 4 to both sides and you get y equals 1/2 x plus 7. Okay, so you shouldn't be worried if you get a fraction. Like that will happen on occasion. Okay,
Okay.
so let's do another one here. I don't like any of these because too many of them give you the y-intercept as one of the points. So I'll just make one up here. So let's say the slope is 1/3 and the point is 9 comma -2. All right. So I want you to first write this in point slope form. And then we'll talk about how to reduce it otherwise.
y plus 2 equals 1/3 parentheses x minus 9.
I'd like you to try simplifying it from here, putting that into slope intercept form, which means you're going to solve for y.
Y equals 1/3 x plus 5.
So it's -3. So this becomes, I think you got some sign issues here. Y plus 2 equals 1/3 x minus 3. Subtract 2 from both sides. And you get y equals 1/3 x minus 5, like that.
Oh, okay. Yeah.
You said +5. I don't know. Maybe you just misspoke. Not sure. All right, let's have you try one here. What did I do here? Yeah, let me have you try another one here. So let's say the slope is -1/5, and it goes to the point -5, -3. So I first want you to write this in point slope form. Again, I know we're doing a lot of the same thing. It's repetition is important here. And then we'll convert it to slope intercept form.
Y plus 3 equals -1/2 plus x plus 5.
Okay, now go ahead and try simplifying this, please. Putting it into slope intercept form.
Y equals -1/5 x minus 4.
Correct? Yeah, good. Really good. Okay. All right, so we're at a good point here to transition to a new topic, which is how to write something in what's called standard form. Okay. So standard form is a little bit different than anything we've seen before. It's ax plus by equals c. So there's a couple of rules for standard form. Notice that x and y are on the left side. okay? A, B, and C are what are called integers, which really means no fractions, no decimals. And then the last thing here is that A is supposed to be greater than 0. Basically, A has to be positive. All right. So I'm going to write, you'd want to have these rules written down. We're going to close out our lesson doing this. So you can decide if you want to do that now or later. But the main thing here is, the X and Y are on the same side, integers, no fractions or decimals, and it's positive. So here's an example. So typically the way this works is they'll give you something that's y equals minus 2x plus 3 like that. So the first thing you do is you always move the x to the same side as the y. So you add 2x to both sides. So this becomes 2x plus 1y equals 3. And what you do is you go back and you say, okay, well, are all the rules satisfied? Are x and y on the same side? Are the coefficients in front of x and y and the number, are they integers? Meaning like no decimals, no fractions. Check. Is the number in front of x positive? And it is. Okay. So no big deal there, right?
Yep.
Here's another example. Let's say it's y equals 5x minus 2. Okay. So this time, well, you subtract 5x from both sides and you get minus 5x plus 1y equals negative 2. You go down your list. Okay, are x and y on the same side? They are. Check. Are the coefficients all integers? They are. Check. That's good. Okay. And then well, last one here. The problem here is that this is negative. So how do you undo that? Well, you multiply everything by -1. So that becomes 5x minus 1y equals 2. And that is your final answer here. Does that make sense?
Yes.
Okay. Next example we'll look at is, well, what do you do if you've got a fraction? Let's say it's like y equals minus 1/3 x plus 2. Okay. Well, you start out the same way you do all the others. You move this to the other side. Okay. So plus 1/3 x plus 1/3 x. Okay. Which means that, sorry, so you have 1/3 x plus 1y equals 2. Problem now is you have a fraction here. So how do you undo a fraction? Well, you multiply everything by the denominator, 3. Okay. So this becomes 1x, or just x, plus 3y equals 6. So notice you multiply everything by 3.
Okay.
Okay, so far?
Yes.
Great. So now the next thing here is, what if it's like, I don't know, 2/5 x minus 1. What do you do here? Well, it's the same thing. You move the x and the y, you move the x to the same side as the y. So you subtract 2/5 x. So you have minus 2/5 x plus 1y equals -1. So even though x and y are on the same side, you got problems here because, first of all, it's not integers. So you have to first clear the fraction. So you clear the fraction by multiplying everything by 5. Okay. Now, I don't know how comfortable you are with this. We'll see as we do some examples, as I have you do some examples, but it's better to actually divide before you multiply. Like, I know the tendency is, okay, 5 times -2 is -10, -10 divided by 5 is -2. If you divide first, it cancels, you get minus 2x plus 5y equals -5. Does that follow that? Is that clear? Any questions?
Yeah,
Okay.
that's clear.
Now, the problem here again is that, well, it's you gotta have that leading one's got to be positive. So you got to multiply everything by -1. Now, what you could have done, you could have multiplied by -5 here. But if you don't, just remember that. So it's 2x minus 5y equals 5. That is your final answer. Any questions on this so far? So I'm going to give you some examples to try.
Nope.
Okay. All right, so first one I'm going to have you try. Let's say it's y equals negative 1x plus 3. I want you to put this into standard form.
One x plus one y equals 3.
Now you don't have to say the 1x and the 1y. You can also do this. X plus y equals 3. Is that clear?
Yes.
All right. Now what if it's y equals 5x minus 2?
Five x plus negative y1 equals 2.
5x minus y equals
2.
positive 2. Yeah, really good. Okay, now we're gonna do some fractions. Fractions are always the toughest here. So let me give you one here. Y equals negative 3/4 x plus 1.
3x plus y equals 4,
3x plus what y?
one way.
Okay. All right, I think maybe you did not, because you should get 3/4 x plus 1y equals 1. And then when you multiply everything by 4, you got to multiply everything, which includes the y term. So it is 3x plus the 4y equals the 4. So it looks like he just didn't multiply that y by 4 there.
Okay, yeah.
See that? So we're kind of in this intensive line stuff. So it's okay that, we didn't really, it's okay. There's a few mistakes there. We're going to have to do this again next time, or just pick up on a new topic because it's a pretty challenging one. So did really well today. Just going to stop a tiny bit early. Go ahead and stop recording.